today is to do lesson 5.3. I'll be honest, this is a lesson I could so easily spend 2 days on, but I just don't have time this week. Okay, so we're going to hit the highlights of lesson 5.3 today. Tomorrow we're going to hit the highlights of lesson 5.4. Wednesday, I plan to give you a review worksheet. Thursday, I do not see you as a class because you're an afternoon class. And Friday morning, you will have my class, and we'll do questions over the review worksheet and then a quiz over the material we've done in Chapter 3. So that is our plan for the week, if you will. Okay? As we look at lesson 5.3, it is solving polynomial equations. I'll be honest, for the most part, we're solving equations using techniques that you already know. Now, on some of them, we are going to kind of tweak things a little bit, maybe go a little bit a step harder or something, but overall, it's just a variety of things you know, okay? Listed right there is some methods of solving polynomials, okay? When we talk about solving an equation, we often talk about factoring. The first step I always try and ask you is there a GCF? And so you'll notice one of the pieces here is factoring GCF. Quadratic factoring, if it's in that form x squared plus bx plus c, we usually try and factor how? If it's like x squared plus bx plus c, we try and factor and ask for a product and sum. Okay. If there happens to be an a value and it's ax squared plus bx plus c, we tend to do a product of ac. We'll review that today. If it doesn't factor and it's quadratic, we might use the quadratic formula. You'll see that today. Differences of squares. As just a brief review, differences of squares. If you're factoring something that's difference of squares, that would be like factoring something like x squared minus 25. Do you remember how to factor something like x squared minus 25?
Isn't it like x minus 5?
Yeah. It goes into two parentheses. You can think square roots to get yourself into those two parentheses, right? Where the square root of x squared is x, so that's the front of each parenthesis. The square root of 25 is 5. And if it multiplies to be a negative, you need a plus and a minus, right? That's factoring the difference of squares, when you have two different perfect squares subtracted. Factoring by grouping. Now, scratch the equal 0 here. I'll be honest, I don't know that I have taught factoring by grouping explicitly, but we have used factoring by grouping. We use factoring by grouping when we are doing our product of AC. In Algebra 1, I feel like you were very likely that you were taught factoring by grouping. Okay? So, let me just review real quick how to do a factoring by grouping, because you'll see a problem in homework that is factoring by grouping like this. As you look at x cubed plus 2x squared minus 3x minus 6, notice there are how many terms here? 4 terms, yes? Think about product of AC. What I usually say, once we have 4 terms, we're going to split this in half. And so when I split it in half, I'm going to split it right after the 2x squared. And then we look at the various GCFs. Okay, so if you forget the back half, x cubed plus 2x squared. Is there a GCF there? Go big or go home. X squared. So if we factor out an x squared of the first two, x cubed divided by x squared leaves me with x plus 2x squared divided by x squared leaves you with 2. Repeat the same thing for the second part of the problem, right? So, block this off. GCF of minus 3x minus 6. They both have a 3 in common. The first term's negative, so make it a negative 3. Negative 3x divided by negative 3. X. Negative 6 divided by negative 3. There's the 2. Like product of AC, we know we've had success because our parentheses match, right? How do you express the final factored form? Okay, almost. So, one of my parentheses, notice what is in common. There is an x plus 2 in common. So one of the parentheses is just an x plus 2. And then what are the other two pieces here? My GCFs of x squared minus 3. So you'd have parentheses of x squared minus 3 and x plus 2. Okay? That's factoring by grouping. You see that when we do product of AC, right? And I'm going to review product of AC here on one of our examples later on. But you've seen that. Just need to review it and call it by name. Now, the one definite new thing I am teaching today is right here in this next spot when we talk about factoring sums and differences of cubes. When we talk about factoring sums and differences of cubes, we're talking about factoring something of the form, and actually, I'm going to do the other example, not this example. So, I'm going to put our formulas over here. When we talk about factoring sums and differences of cubes, we're talking about factoring items in that form that are a cubed plus b cubed and a cubed minus b cubed. Now, here's the deal. We haven't factored this before. So as I said, this is not something I'm expecting you to know how to factor at this point. This is new, most likely, to you. So it's a sum of cubes because it's 2 cubes added, a difference of cubes because it's 2 cubes subtracted. I'm going to go ahead and write the formulas down, and then we'll use it to factor that 27x cubed minus 64. So when you factor a cubed plus b cubed, it's 2 parentheses. The first parenthesis is a plus b. It's a cube root of each, keeping the sign the same. And then the other parenthesis is a trinomial, and it's a squared minus ab plus b squared. And again, I'm going to go through an example and help you set that up. Okay? With a cubed minus b cubed, you just change 2 little signs. Instead of a plus b, we're going to say a minus b. And then over here, you change the middle sign again. So it's a squared plus ab and still plus b squared. I would have this next to you while you're doing homework. Okay, you have 2 that involve cubes tonight, and you'll want these setups with you to try and help you. Now, you're saying, great, Mrs. Sargent, you gave us a setup, but how the heck do we use it? Let's talk about that. As we look at 27x cubed minus 64, notice this is in what form? This is an a cubed minus b cubed. Okay, and I say it's an a cubed minus b cubed because both of those terms are what I would call perfect cubes. So before we proceed, let's talk about what is the cube root of the first term. So what is the cube root of 27x cubed? 3 what? No? Right, but look at what I'm wanting. I'm wanting the cube root of 27x cubed, so 3x. Because cube root of 27 is what number times itself 3 times, right? So 3 times 3 is 9, times 3 is 27. So that's 3 and then x. That right there, because we just took the cube root of the a cubed term, 3x is what we're going to use anytime we see an a in our formula. We're going to put 3x into that factoring. And then let's do the same thing with the other part. The cube root of 64. What number times itself? Times itself again gives you 64. No, I don't take the negative with it. At least the way I teach it. 4. Yeah, I keep that sign in the middle just as it tells me which signs to put where. So I don't take that with the number. I just look at the number. So cube root of 64 is 4. 4 times 4 is 16. Times another 4 is 64. And that is your B value. 2-second calculator lesson. Do you guys know how to do a cube root on your calculator? They do it. I promise. Any scientific graphing calculator is going to do a cube root. Okay, so my square root symbol is right here. The cube root, or any root, is the one that's the x root. That's the one you want to do. So if I'm going to do a cube root, on my calculator, I type 3 first, and then I'm going to do that. That right there says, okay, on my calculator, 3 is going in place of x, and so I'm going to do the cube root of whatever I type next. So if I do the cube root of 64, there's my 4. Okay? Any scientific graphing calculator is going to have a way to do a cube root. It's just a matter of figuring out how your calculator works. Okay? And I can help you with that later if you need it. Now, let's set this up. We found our 2 cube roots, so we're going to use those as a and b values. This is a cubed minus b cubed, so over here, the first parenthesis I'm going to do is a minus b. So my a value, being the cube root of 27x cubed, was 3x. Since the sign in the problem is a minus, I'm going to say minus b, the cube root of 64, which was 4. So 3x minus 4. Second parenthesis, a squared. So whatever was first in your first parenthesis, square that. So 3x quantity squared. What's 3x quantity squared? Not 3x squared. 9x squared. When you're squaring it, you're squaring the whole term. So 9x squared. Notice, change the sign, it's plus and it says AB. So 3x times 4, and 3x times 4 is 12x. It's always plus b squared, and b is 4, so plus 16. We'll practice solving one of these later. I just wanted to practice the factoring with you, because that is hugely important right there, is knowing how to factor. And I get it, it's brand new. It's going to be a work in progress. But I'm at least trying to give you the tools to try it. Okay? Questions there? Okay, I have about 3 examples picked out. As I said, I could easily spend 2 full days on this lesson. There's so much we could talk about. But let's talk about example A. A says, what are the real or imaginary solutions of each polynomial equation? 2x to the third minus 5x squared equals 3x. What's your guess of where to start? What would you guess? And what's subtracting 3x do for us? Yeah, don't we often, when we're solving these more complicated equations, we make it equal to 0? That's exactly what we're going to do. So, subtract 3x. And when we subtract 3x, we're going to have 2x cubed minus 5x squared minus 3x equals 0. Okay? Thoughts next? Is there a GCF? X? Anything else? The highest it has is the next to the first that they all have. So we're going to factor out GCF of X. Notice I'm going to put that X out front. When you divide by X, what does that do to all the powers? Takes each power 1 down, right? So 2x cubed becomes 2x squared minus 5x to the first minus 3. Okay, so GCF. You will see some GCFs in homework today, so beware. Now, look at that 2x squared minus 5x minus 3. Factoring thoughts on that? What? They don't all divide by 2, though. Yeah, we're not going decimals. Okay. Notice, do you see ax squared plus bx plus c? How do we factor something when it's in the form ax squared plus bx plus c? Product of AC? Okay. That's exactly what we're going to talk about here is product of AC. What are my A and C values if we're doing product of AC? 2 and negative 3. And 2 times negative 3 is negative 6. I'm doing a product of negative 6 and a sum of negative 5. What multiplies to be negative 6 and adds to be negative 5? Okay. Negative 6, positive 1. Now, okay guys, here's the trick. Remember, do I just get to put these in parentheses and call it done? No, when we're doing product of AC, what do you do with those two numbers once you get them? Yeah, we split that middle term, don't we? So negative 5x is going to split into negative 6x plus 1x. So we're using the two numbers we just came up with. What about the 2x squared? And the minus 3. They just carry down. Now, here's the other thing, folks. Remember that x out front? You have to continue carrying that x down. We're trying to solve an equation. That x represents an answer. If you throw that x out the window, you've just thrown an answer away, which some of you may not care about, but the grading will show it. Okay? So, now, what's that mean about this next step? This x is going to carry down. Okay, in the parentheses here, there are how many terms? 4. So we're going to split in half. We did this earlier with factoring by grouping, right? So the x carried down out front. I put a pair of brackets here to kind of keep things organized. What do 2x squared and 6x both divide by? 2 what? X. So I'm going to put a 2x here. 2x squared divided by 2x is x minus 6x divided by 2x, 3. Okay. GCF of the second half. What do 1x and minus 3 both divide by? If all else fails, there's nothing else in common, there's still a 1 in common. And what happens when you divide by 1? 1x divided by 1 is still x. Minus 3 divided by 1 is still minus 3. Guess what? The x out on front carries down still. And the rest of it's going to be in 2 parentheses. Does that sound familiar? What's one of the parentheses? My GCFs of 2x plus 1. What's my other parenthesis? The common factor of x minus 3. Am I done? No, because I haven't solved, right? Set them equal to 0. All I've done is factor. Now, the good news is we're almost there, right? This is the easy step. This is a step, if you've made it this far, this is the home free stretch. We're going to, how many things do I set equal to 0 here? All of them, which is a total of 3. Because what, besides the 2 parentheses, we also have to include x. So we're going to have x equals 0, 2x plus 1 equals 0, and x minus 3 equals 0. What solutions do I have? Okay, x equals, don't forget the 0. We have the positive 3 down here, and then what about 2x plus 1? You subtract 1, 2x equals negative 1, and then you would divide by 2, so negative 1/2. Does it make sense I have 3 answers? Yes, because the highest power is x to the 3rd. So that means I'm going to have a total of 3 answers. They might not all be real, but I'm going to have 3 total answers. Is that a good review of product of AC? I graded the test over the weekend. They are in Skyward. I will say, some of you still need practice on figuring out product of AC. And going forward, we still use product of AC. Okay? So you have to keep working at figuring that out. Some of you have got it. Some of you haven't got it. And I think some of you, if you just sit down and practice it and try and figure it out, I think you figure it out. I really do. Okay. Backside. Again, as I said, I'm jumping. We're going to go to the backside, and we're going to try example E. X to the 4th minus 3x squared equals 4. Take a guess on that first step. Well, plus 4 or minus 4, which is it? Okay. And why are we going to minus 4? Yeah, again, try and make this equation equal to 0. And so in order to do that, subtract 4 from both sides. So then I have the equation, x to the 4th minus 3x squared minus 4 equals 0. Now, does that look familiar to anything else we've done? Huh? Okay, looks like literally every other thing we've done, except what's slightly different. Yeah, normally when we do this type of problem, it's x squared minus 3x minus 4. Now those exponents are doubled, aren't they? X to the 4th minus 3x squared minus 4. So basically what I want you to think about, when we're going to factor this, and I'm going to have you think this as a squared minus 3a minus 4. If I have you think of that as a squared minus 3a minus 4, can you do that problem? We should have an idea. If I think of it like that, Can we factor? This is in our form, x squared plus bx plus c. So what do you know about a squared for right now? A squared breaks up into a times a. And then you need numbers that give you what? A product of -4, a sum of -3. What gives me a product of -4 and a sum of -3? -4 and +1? Now, you know how to solve this, yes? Except here's the catch. Was it really a times a? No. If this was x to the 4th, what really would they have been? X squared times x squared? So let me convert back to my x's. And instead of thinking a minus 4, x squared minus 4. Instead of a plus 1, x squared plus 1. So basically, every time I put an a in, I was putting it in for x squared. Okay, that's exactly what I did there. Is I let a equals x squared. But if that confuses you, don't worry about it. Just, oh, okay, x squared and x squared. How do I continue to solve from here? What? Okay. Two factors multiplying to equal 0. In order to solve, we're going to set each part equal to 0. X squared minus 4 equals 0, and x squared plus 1 equals 0. How do we solve if it's x squared minus 4? I can't square root yet. Yeah, since it's just x squared, I can get x squared by itself. Since it's x squared minus 4, I can add 4. And then I'm going to have x squared equals 4. If x squared equals 4, we're going to square root. Good. What happens when I square root x squared equals 4? X equals 2 and -2. Or in other words, plus or minus 2. Remember when you take an equation in let me rephrase that, a square root in equation setting, plus or minus. Okay. X squared plus 1 equals 0. How do I solve that? If it's x squared plus 1, we're going to subtract 1. X squared equals -1. How do I solve? Square root. What's the square root of -1? I. And plus or minus I. How many solutions did I get there? Officially, 4. Positive 2, -2. There's 2 reals. Positive I, negative I. There's 2. Okay. So, my point is, yes, we saw a power or a higher power. We saw x to the 4th instead of x squared. However, we used factoring we already knew. We used skills we already knew there. Okay, the other example we're going to look at is I. So make sure you have what you need because I'm getting ready to scoop the paper. If you're ready, start looking at I. What's the first step we have to do on problem I? Set equal to 0. Before we set equal to 0, distribute. Okay. I was leaving that up there for a moment to make sure everyone had what they need. So, okay. So we're going to distribute and make it equal to 0. So distributing This becomes x to the third plus 8x equals 8x plus 8. And then if I'm going to make it equal to 0, we want to subtract 8x and subtract 8. Then I'm going to have x cubed minus 8 equals 0. Okay. The short of it, well, I've already got equal to 0. Here's what I will tell you. You cannot just add the 8 over and take the cube root. Now, if you add the 8 over and take the cube root, you will get one of your 3 answers. And here's the deal. You're going to get the real answer. Okay? So if you're only looking for real answers, it works. But we're looking for all real and imaginary. So in order to get the 2 imaginary, I showed you some factoring like this. Yes. X cubed minus 8 is in the form a cubed minus b cubed. And that's what we're going to look at here. Okay. If we think of this in the form of a cubed minus b cubed, well, let me write down what I had from the other side. It was going to be a minus b times a squared plus ab plus b squared. That's straight from your front side of your notes, right? I've already told you that. I've already written it down for you. Now, before we get started, my suggestion, figure out what a and b are. If x cubed is in the place of a cubed, what do we do to find a? We're going to take the cube root of x cubed. What's the cube root of x cubed? X. So every time we see an a, we're going to replace it with x. Do the same thing for the other term. It's 8. What's the cube root of 8? Just go with 2. And that 2 is going to go in place of what? That's your b value. Okay? Ready to set up the factoring? A minus b. So, what's a minus b? X minus 2. It's the cube roots, right? Second parenthesis. A squared. So that's going to be x raised to the power of 2, which is x squared, plus ab. Plus, a and b are x and 2, so x times 2, or in other words, 2x, plus b squared. What's b? 2 squared, which is 4. And officially equal to 0. Okay. I've got 2 factors multiplying to equal 0. What do I officially do? Set them each equal to 0. So we've got x minus 2 equals 0 and x squared plus 2x plus 4 equals 0. Get your easy answer out of the way. If x minus 2 equals 0, what do you know? Add 2, x equals 2. There's your real answer. What about x squared plus 2x plus 4? What? Okay, factor. What multiplies to be 4 and adds to be 2? Multiplying to be 4 is 2 and 2 or 1 and 3. Can we make, or 1 and 4, I mean. Can we make either of those work? No. What's the backup plan when factoring fails? What's the backup plan when factoring fails? Nope, it doesn't factor. Factoring has failed us. What do you have a song for? Quadratic formula. Here we go. I'm running out of time, guys. We got to go. X equals negative b, negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is 4, all over 2a, 2 times 1. Okay, clean up. Negative 2 plus or minus 2 squared is 4. 4 times 1 times 4 is 16. What's 4 minus 16? Negative 12 all over 2. I'm going to run out of room here. Okay, guys, side note. Square root of negative 12. What do you know about square root of negative 12? What'd you say? Okay. Okay. So it's a negative 12, so we pull a negative 1 out, which is going to be an I. The square root of 4 is 2, so 2i, and the square root of 3 stays square root of 3. Okay, so negative 2 plus or minus 2i square root of 3 all over 2. One final simplifying step. Everybody divides by 2, don't they? So negative 2 divided by 2, negative 1, plus or minus 2i radical 3 divided by 2. I square root of 3. So we have negative 1 plus or minus I square root of 3. And, don't forget, we had an answer of x equals 2. How many answers did I end up with? 3. Because negative 1 plus I radical 3, negative 1 minus I radical 3, and 2. Okay, it's important that you factor here and get those imaginary numbers. Your homework has 8 problems in it. Okay, you will see several of the topics we talked about. Lesson 5.3 in Math Excel. Have that done for tomorrow.